Hi guys. So I'm just making a lesson and assignment for you guys on esters, which is the next part of the topic. The first two learning intentions you're going to do on your own using this information that I've linked in here and using this iPad. So I'm going to assume you've already done that part, so I don't have to recover things. What I will be doing is looking at this learning intention and then some from part two. So first of all, how are esters made? Oh gosh, wrong place. Here we go. So esters are made by combining carboxylic acid and an alcohol, and that makes the functional group of an ester, which is the carbon to oxygen double bond, which is then bonded to an oxygen, and then you've got a carbon group down here and a carbon group down here. So this diagram here is quite nice because it shows us different colors of what's happening here. So when the carboxylic acid combines with the alcohol, the carboxylic acid loses its OH group. Okay, the alcohol, which has the functional group of OH, loses its H group. Okay, and then you can see that this oxygen here is going to bond to that carbon. The OH and the H are removed to form water, and that's how we get our functional group there. Here's another diagram just to help explain if that one didn't make sense. Here is a carboxylic acid. Carboxylic acids, carbon to oxygen double bond, carbon to oxygen, and then OH, and the alcohol has the OH. The OH from the acid and the H from the alcohol are removed, and then we join across there, as you can see that functional group there. So it's called a condensation reaction because we're removing water. We're combining two bigger molecules and removing water. Now, of course, we covered a little bit of ester formation in carboxylic acids topic. Okay, I want to move on to our next part of the lesson. So the reason I've split it up in part one and part two is just kind of the basics of esters. Part two is slightly more in depth, and it's actually the main part of where exam questions are around. So we're going to look at hydrolysis of esters. It was really important for me to show you how esters are formed because we're going to look at hydrolysis of esters, which is essentially the reverse of that. The word hydrolysis is split up two parts of words. So lysis in Latin means splitting. Hydro means water. So we're going to be splitting esters using water. Now I'm going to your SciPad here, so we're looking at page 200, and we're going to look here. So if we react an ester with water, we must have a catalyst, either an acid or a base catalyst. And this example is an acid catalyst. Our products are carboxylic acid and alcohol. You'll notice that this is the exact reverse of the formation of esters. What we just looked at just before was carboxylic acid plus alcohol goes to an ester and water. So this is the exact reverse of what we've just seen. So these two pages in your SciPad go through the two forms of hydrolysis. There is acidic hydrolysis and there is basic hydrolysis. So this page is going to be looking at acidic hydrolysis. What I want to do is just go down to this example question here. So this question here, just to use as an example. The first thing is we need to be able to recognize where the ester is splitting, where the hydrolysis is occurring. So first of all, remember they are formed from a carboxylic acid and an alcohol. And on the carboxylic acid, when they form, it loses its OH. So I'm going to draw a line here to represent where this is going to split. This is my carboxylic acid and this is my alcohol. And you can see here that this particular question in your book has split it up to make it easier. So the alcohol, which is this part here, is 2 carbons, is ethanol. The carboxylic acid has 1 carbon, so it's methanoic acid. Same thing, let's show where this next one is splitting. Okay, it's splitting there. So now we have our alcohol here, which is ethanol, and we have our carboxylic acid, 1, 2, 3 carbons, is propanoic acid. Okay, I'm telling you the answers here, but you need to draw it out, which is the more difficult part. Again, the next one, you might want to pause the video and make sure you kind of think about it. Where is it splitting here? Okay, cool, it's splitting there. So this is our alcohol part. So we've got methanol, and this is our carboxylic acid part, 1, 2 carbons, that is ethanoic acid. Okay, so that is acid splitting. Oh, let's see this, clear that. There we go. So that is acid hydrolysis. Okay, let's have a look at base hydrolysis. So actually, let's just quickly go back to acid hydrolysis. Ester plus water, and we're using acid conditions, forms carboxylic acid and alcohol. Over here, base conditions. Ester plus water. Okay, a base has water in it, and it's OH minus as the catalyst. So ester plus base goes to metal salt plus alcohol. So before it was carboxylic acid and alcohol. Here it is metal salt and alcohol. I want to go through why it's not the same product. If I have base present in this reaction here, if I had base present in this reaction, could I get a carboxylic acid being formed? I want you to think, if you've got a solution of base, if you've got a beaker, you put some acid in it, you put some water, and you put a whole pile of base in there to catalyze it, can you form a carboxylic acid? Well, the answer is no, because you've got OH minus ions present. If there are OH minus ions present, you're not going to form an acid because the acid and OH minus ions are just simply going to straight away react with each other. So what you actually get is an ion. Okay, so let's have a look at this example here. Here is our ester. It's going to break here. Here's our carboxylic acid part. Here's our alcohol part. Now, if you've got sodium hydroxide present, you can't have carboxylic acid. You can't have an acid and a base just present and sitting there. They're going to react with each other at all times. So what happens when a carboxylic acid reacts with a base? Well, if we kind of get rid of that part, the carboxylic acid, it's a bit squiggly, sorry. Oh, that's supposed to be an H, is going to look like this. Okay, it's got the carbon to oxygen double bond and then the carbon to OH. Now, this is going to react straight away with the acid, and when it reacts with the base, and when it reacts with the base, it donates its proton because it's an acid. It donates this H, and the base it donates the H to the OH. So the H from the acid goes to the OH and forms water, which is a neutralization reaction, and so you get a carboxylate salt, a carboxylate ion. Okay, instead, the alcohol is exactly the same. So I just want to make sure that this is you're understanding that this is really, really simple. The only difference between this reaction and that reaction, you both get alcohol formed. The only difference is you get carboxylic acid here. Okay, over this one you get carboxylate ion. The only difference between acid and base hydrolysis is that the acid will, during acid hydrolysis, this will have an H here. When it's base hydrolysis, the H has been donated, so it's going to be an O and a minus. Now you're going to have to do practice of this, okay? But that hydrolysis is really important. I'm going to quickly go back, here. I'm going to make another video just to kind of break it up about the next two learning objectives. Okay, thanks guys.